Recording is in progress. Good morning for the first time, y'all. This is for the first time hotel, evenings and weekends, week 6, day 4. Um, we're on Docker. Man, I was picking on full time and everything, and I just don't have it in me. We learned Docker in fundamentals because we think it's important. We'll be doing Docker throughout this program, sifting it into everything, making it easier, making it work for us, making it, we don't have to have some weird borked local install when we release you out into the world. You're going to understand how to do things in a container, in a safe place where other people can run it. Um, Goodness gracious. Docker, if this has ever happened to you, yada yada, you write a Python program on your local machine, and you're using the latest Python. Later, you try to run it on a separate machine. Doesn't work. This is very common. This is common going from Python 3.13 to 3.12. In fact, and I'm not calling anybody out, this is a normal thing. Cisco's assessment 1, Tiffany said this doesn't work at all. And I said it works fine on my machine. I don't know the exact reason, but I think she was using a much older Python version. Um, some small syntax changes. This happens a lot, and it's going to for sure happen between Python 2.7 and 3 plus. F strings, format strings were invented in Python 3.6. So you certainly didn't have those in Python 2.7. Not to mention the all the numerous bug fixes and libraries and feature adds we've had since this was officially deprecated in 2020. But people will still be running Python 2.7 until I'm long gone, I'm sure. It's very difficult to get rid of old code. There's no financial benefit often in updating your code. If it just works, it works, right? Uh, it can be very difficult to update things. So your options, if you were on a new machine, would be to adjust your code to make it run on Python 2.7, which you probably don't want to do. It's not a lovely language in comparison. Or you update the version of Python on the computer you are currently using to run it. Not always possible. We have the advantage of running our own machines in this class, and we do what we want. But if I was putting you on a machine you don't own, you might not even have permissions to install anything, right? You need root access, and if you don't have that, which is very common, we got to figure something else. Um, Assuming you had a very easy solution, this is already frustrating. If you had a much larger millions of lines of code, program, good luck. Uh, but we have an easy way to fix that. And we can still fix that to the day. You can Dockerize just about anything. Anyways, Docker. This is the Docker whale. Uh, Docker will take your program, wrap it up with everything it needs to run, maybe that Python version right there. So wherever you run it, it has everything it needs. As long as your machine has Docker installed on it, you should be able to run anything that is in a Docker container for the most part. There's very minor little things that we can get around a lot of the times, but uh, you'll see some strangeness. Um, as I said, this technology is containerization. It comes from a metaphor of the shipping industry. If you care, I think we know what a container is. Like I've got food in a container in my refrigerator. It's everything I need. I don't need anything else. I throw it all in there. I don't know, the analogy kind of falls apart when you really compare it to a shipping container. Uh, how would Docker even know what everything our app needs to run? Well, we have a Docker file to tell it. This is going to be everything we need to spin up a Docker container with Python, run some Python, and run. Let me trash that. It's right here. Y'all, this is fairly straightforward. If you haven't looked at Docker file before, you can probably guess. Art, what is your 4.0 answer for what line 1 might be doing?
That to me looks like it's just kind of like importing. It's telling me like where to grab from.
It's kind of an import. I could agree with you that importing. What are we importing?
Um, probably not only the file, but all the details that come along with the file that you want to put into Docker.
Well, what is this? What were we talking about in the lecture?
The version Python.
Yeah, we're going to pull in a version of Python too.
You know,
And
you
I don't
know,
know if I go ahead.
uh, uh, kind of made me think like if we're worried about different versions of Python and Docker being the solution, are we also going to have to consider different versions of Docker?
No, not often. Not too often. Different versions of Docker will come with different features and allow you to do different things, but generally Docker should be pretty reverse compatible unless you're using a very old version of it. That doesn't come into play often in my experience. Workdir, what does that seem like, Cisco?
It's basically getting the path of the workspace directory that you're working out of, or the main working directory.
That's where our stuff is. Probably we're going to be installing things, putting things. I
Mm-hmm.
agree. What is this? Adam? In Bash, it would look like this. And it's okay to not have a
Oh,
great
I was
answer for
muted.
real. Oh, yeah, go ahead.
It's just going to copy a certain file.
Yeah, and put it here. So, what that really means, copy hi.py from my local machine, put it in Workdir. Basically, like, hey, when you build this image, take it, well, not put it in image is the right answer, I guess, but it's going to end up in the work directory. And then this command. What's that doing, Joe?
Running the actual the command to actually execute it. So in Python and the file itself.
Yep, it's easy peasy. It's an uglier way to say, hey, I want you to do this. But we're telling it you need to run a command. The command is two things. Run this command, put a space, run this command. Looks a little janky, but this is the way it works, the way it reads. So nothing crazy, no magic. We're not just copy pasting a Docker file with no concern for what it's doing. We're not just saying, yeah, it works. We can read this, right? I'm never going to be seeing too much stuff in a Docker file that I can't more or less explain. And I want it to be the same way for y'all. Yeah, this gives us all the answers, but we figured it out. And in short, hey, Docker, stand me up a container that has Python 2. I want you to put stuff in this directory because I want you to pull from my code this hi.py file and put it in that image that we're building. The Docker file builds an image. Run this. When you run the image, it should do this. It is just that easy. But before we start actually creating containers, we'll need to create an account. I've done it. Once you create an account, you'll be able to pull images and create your own. To get this to work, we need to be logged into Docker. If you have not yet created that account, you can go for it. Make sure you're still paying attention. I've done so as well. Okay, so this wants us to go search for this image. File not found. Oopsie doopsie. Oh, what? What is docker.com? That's not linked properly. Let's go to Docker Hub. And it wants to find a Python 2.7 image. I am already signed in. Not Docker. Python 2.7. That's what I'm looking for? What is this? Python. This is Python. What's the version? Oh, this is 3.14. I want 2. Maybe if I search it the exact way that it's looking for. Is that going to give me what I want? I'm having a harder time pulling this. Surely this image hasn't been removed since the last time I taught this. Interesting. Well, maybe from here, we've got different versions we're able to pull. Well, this is what it wants. If you want a different version, simply specify it like that. They're all wrapped up into here. I don't think this is showing all the available tags. We'll see what happens though. So to get that, you run Docker login. I should be logged in. I literally just ran this. How am I logged in? Oh, I restarted my machine. Oops. Okay, we're logged in now. Great. One piece of the puzzle that I need to do now, and I'm glad I restarted my machine. If you've got Docker desktop installed, you make sure that's running. Docker needs to be up and alive. Oh, look, it's Golf Platoon. Trash. You need to have Docker running in the background to be able to command it. It's not an executable. It is a daemon that's running all the time that we're going to hit. So this is good to go. Docker's up. Docker's good. If I didn't have that, maybe I could display what you would see. I'll show you all in a second. Hey, stop. All right, we're logged in. So let's change into the directory. Call it Dockerfile. I'm already there. We're going to run this command. And then we're going to talk about this command. Docker build-t Python says hi. Here. Not found. Oh, because I didn't call it hi.py. It doesn't tell me to do that, though. What's going on here? Am I losing my mind? Rename hi.py. What does hi.py say? Hello. All right. I ran a command. This is saying Docker, build an image, and then tag it. Python says hi. This is going to be the tag. This is going to be the name of it in a way. And what do I want you to build it from? Right here. Dot means here, right? And that means it's going to use. No. Wow. It's going to use this Docker file. The Docker command, Docker build is just looking for a Docker file. It finds this one right here. And what did all this stuff mean? Ugh, I don't like reading terminal output. Too bad. From Docker IO library Python 2, there's all the stuff. It found it. It resolved it. What's it doing? It's getting and extracting and setting up an image with Python 2 in it. That's step 1. Step 2, set the working directory. Bam, easy peasy. Copy hi.py, exporting to image, exporting layers, yada, yada, yada. It does all this stuff. Basically, it did what we said it was going to do. It went to Docker Hub. It grabbed Python 2. It set a working directory. It copied hi.py into our working directory of this image. And it's got our command. This is an entry point kind of thing. When I invoke this command, it should run this. But where did it go? I sure like the terminal, but oh goodness, I got all kinds of junk running, but this is good because you can see my other stuff. That should have all pruned though. What's going on here? Yeah, there they are. Let's trash those. So these are my images in my Docker desktop. cool, fun, nice to look at. If you're a terminal person, I claim to be, it's all here as well. I ran Docker images, it's there. If I want to remove any of these, I can do it as such. Is that going to get it? Or do I need the ID? Yeah, I don't think so. So we need to use the image ID to remove these normally. You can type out this whole image here and it should get it. Why? Docker. What's going on here? This should have cleaned up. All right, we gotta delete the image directly. That should work. If we do Docker images again, you can see that's gone. One kind of quick thing, I don't need to type that whole image out. I just need it to match. Docker will read from left to right. Notice this one's 065, blah, blah, blah. This one's 4, FFF. I wanted to delete this one. I just give it a 4, and that should be good. Of course, it's not going to do that for everybody. We stop a running image, that's fine. It doesn't like it when you're trying to delete old images. I'm sorry. These version changes. Oh, and to show you, Jordan, that seems like a lot to futz with. Delete. That's fine too. This is the only image we built that we know about that y'all guys have seen. There's our Python, says hi. We can look at it. This is the layers. Don't worry over much about layers at this moment. But it's basically all the different, I don't know, layers that are required to run this image. Great. It work. Seems like a lot of overhead to print a few words, which is literally what all you are thinking probably right now. It is, but it's so much more than that. So this image exists. It's right here. We can hit it anytime, wherever. To run it. Oh, no, let's run it this way first. Because that image exists, I can say, hey, Docker, run that image that I've got locally. Whoa, look at that. I didn't run the file. That's different than doing this. Because that wouldn't really run on my machine. I don't want to go off script. I think this lecture covers this perfectly later. All right. We can run this in a couple ways. I guess what's important here is this image. What is an image? It is what I said it was. It is a machine that has everything I need to run this script. It still exists on my machine. It's up. Well, it kills itself. It's still around. Other image builders. There it is. Created. There it is. If I wanted to get into that thing, I could run it and then enter it. What does IT mean? Like always, if you're not sure about commands, different flags, we can do -- help and figure out what these commands are. I'm using I, so interactive. Keep standard in open, even if it is not attached. And then TTY, allocate a pseudo TTY. This is going to basically let us make a connection to this image when I'm running it. I'm going to use bash to interact with it. Love bash. Whoa. This is important. I've spun up this image that I created, and it's just open, right? There's our hideout.py file inside of this image, this ephemeral thing that's going to die when I turn it off. But right now it's alive. This is everything that I need to run this file. This is Python 2. This is my user source. I'm pretty sure we can get to the user source app, which is, by the way, where it put us. Oh, I didn't have to do that. Look, it even says when I connected to this thing, that is the working directory. That's our entry point that we got into here. That's where it put us, and that's where it slapped this file. I can go to other places and get lost, sure. But if I want to get to where I put that file, we need to, get back to it. This is a machine of sorts. Yeah, it doesn't know what that is. This is some kind of image running a machine. All that is required to run Python. It's probably Ubuntu based. We're not going to get too deep into the weeds on that. Let's check what version of Python is running in this container. Hey, Python 2.7. We're really in it. This isn't local. This isn't my machine. It's my machine running a machine. There's a Tropic Thunder bit in there somewhere. I'm not finding it this morning, but it's
Dude.
yeah, I'm a
I
dude
knew
playing it.
exactly what you were going for there. I knew it.
I
My
wasn't
brain-
going for it, but it came up. I watched that.
Great
I love
movie.
seeing stuff on that. It's always people are like, you could never make this movie again. Oh, all right, great. Now let's check. Oh, duh. I'm too Linux brained right now. This is what we stood up. A Debian new Linux 10 Buster, but LSB release only works in Ubuntu. Name Debian new Linux version 10 Buster, yada yada. Doesn't matter so much. If you want to learn more about Debian, it gives you links to it. But this is a Debian machine. Debian. I don't know. Say what you want. GIF. Except there is a right answer here. This machine exists only to run my Python and then die. It's gone. That little machine is gone. Until I run it again, that image just killed that virtual machine. Don't call it a VM. It's kind of a VM. Started up that version of an OS with my file in it to do one thing and then die. It's like, what is your purpose? You run hi.py. That is it. That's like buying a brand new computer, setting it up, installing it, giving it credentials, making it run one file, and then throwing it in the garbage. Very heavy to run hi.py, but it's a start, right? And again, I didn't even show you. We're in there. Let's start it back up, bring it back to life, resurrect it. Check it out. We can run hi.py here. What I wanted to show is if hi.py follows, we'll do it this way. Can I edit things on here? I should be able to do, oh gosh, dang it. Here's the fun thing you'll run into very often. When you build an image, you give it everything it needs to run and probably nothing else. That means Vim is sure as heck not installed on this. Let's get fancy. All right, it does have cat. Oh, it doesn't like that at all. Oh, not cat. I'm sorry. There we go. All right, now going off script, and I shouldn't do that. Hey, that runs. What did I do? Here's our hi.py file. I typed the word echo, which just spits out whatever I do. But I piped it, meaning, hey, the output, the standard out, topically for today, the standard out, I want you to write it to this file. If I wanted to append to that file, I would use to, and it will add it to the bottom line. I wrote it. Hi.py has been updated at 1509. 1509 is the time it thinks it is right now. Yeah, and this machine's, oh, it's UTC. Wonderful. If we look at hi.py, it now says hello. We need to fix that. It only has this line, print space hello. And it ran it. Up here, let's get out of that. Let's kill that container. Would that work on my machine? Heck no, it wouldn't. We're really no S. No, I can't watch my cursing. We are legitimately running a Python 2 container. That's what I'm trying to get across. I want us all to understand. I know we're just running a single file, but I literally can't run that file on my machine because I don't have Python 2. And I don't even know if I can install Python 2 or I'd want to do that to my lovely little Mac Mini here. But instead of changing this massive code base, this massive, 2 lines, we have stood up an image that can run it. Does that make sense to everyone? Doesn't work on my machine. I'm going to build a machine it does work on. Lovely, lovely, lovely. How do you know if it's really running? Docker. Oh, Jordan. That's what I was looking for earlier. This is going to not show that. Okay. This will show all of the running images on my machine. Notice it's 3 times I've started up and killed this thing and it says exited. We can keep stuff alive and it would just continue to run and be alive. But Docker PS process, PS, snapshot of current processes running on the system. Yeah. So Docker PS is what are all the Docker processes running on this system? You should be able to see them here. Yeah, there they are. I don't like building over reliance on Docker desktop, but it is handy. I'm not going to tell you not to use it. Docker PS lists all the currently running, yada yada. If you want to see all the containers in your machine, including the ones that aren't running, use dash A. Again, we don't have to remember anything. We don't want to. We've got the help command here that can show us. I want to see all of them. You can filter them all. Give me the last int, yada yada. Keep it quiet, whatever. As exciting as our application is, we're probably going to want to stop it at some point. There are a couple ways to reference a container, yada yada. You can stop it. Docker stop, not Docker RM, Jordan. I tried to peddle to you fine people earlier. We can Docker stop. And like I said, I'm pretty sure we can get away with that. Docker stop 8. Which one's 8? Well, the one that has the 8 right here. If the next one was 8B, 8 Bravo, we would need to specify because it'd be like, I'm not sure which one you're trying to get rid of. Did it stop? It stopped it. It didn't remove it. We'll clean it up later. Oh, okay, sorry. It stopped it, but we didn't remove it. Anyways. All right. Way ahead of you, machine. Way ahead of you. So what this wants to do is prove what I proved. Adding, except it wants to prove it a different way. I tried to run Python 2 on my machine, and it didn't run it at all. But when I ran it in the Python 2 container, it ran just fine. That's the test. I think that's all I want to show for today. We get more into this with these Docker introduction challenges. But questions about this lecture, about Docker, about anything I've shown,